Hi, everybody. In this video, we are going to do 8th grade GG 14. Doesn't say 14 here, but it's this one. Checkpoint two-way frequency tables. And the first question is, Reba wants to be an engineer, so she worked as an intern for an engineering company over the summer. She asked 40 of the company's engineers whether they preferred math or science in high school. They preferred math, obviously, because everyone prefers math, right? This table shows the relative frequencies from the survey. Okay, so out of all the people surveyed, 20% of them were electrical engineers who like math. 35% of them were electrical engineers who like science. 30% of them were mechanical engineers who like math. And 15% were mechanical engineers who like science. And then here are the totals over here. Remember, since this is a relative frequency table, this will always be 1, or as a percent, it'll be 100%. Okay, for just a frequency table that tells you how many of something there are, this could be anything. But if it's a relative frequency table, then this will always be 1 if it's in decimal form, or 100% if it's in percent form. So the question is, how many more electrical engineers preferred science than preferred math in high school? So we know that she asked 40 people, okay, and what was the percentage of people who were electrical engineers who preferred science? Electrical engineer for science, then math. Okay, so we're looking only at the electrical engineers. All right. 20% of all the people were electrical engineers who preferred math. And we know that there were 40%, there were 40 people altogether. All right. So we need to do 40 times 0.2, and that'll give us 8. So that means that there were 8 electrical engineers who prefer math. And what else do we need? Electrical engineers who prefer science, right? Okay, so now we need to do, oops, now we need to do 40 again, which is how many people there were, all right, times 0.35. And that's 14. So there were 40 people altogether, right? 35% of them were electrical engineers who like science. So how many people is that? What is 35% of 40? That's what we just did in the calculator, and that's 14. Okay, and now we can answer the question here. How many more electrical engineers prefer science than math in high school? So now we're just going to do 14 minus 8 is 6, right? Just do 14 minus 8 is 6, and that's the answer. There are 6 more of these people than these people. So remember, the relative frequencies don't tell you how many people there are in that box. They just tell you what percent of all the people. If you want to know how many people there are over here or over here, then you have to take the total number of people and multiply it by that percent. Okay, so 6 is the answer for this one. Lena asked 80 students whether they like math or science class better. Obviously math, right? This table shows the results. Okay, based on the data in the table, which of the following statements are true? Select all that apply. All right, so we have a boy is more likely to prefer math than to prefer science. So let's look at the boys. 16 liked math and 21 liked science. Wait a minute, there must be a mistake here. How can people like a subject other than math more than math? That doesn't make any sense. All right, well, anyway, somebody at IXL obviously made a mistake here, but let's just go with these numbers. So there were 16 boys who like math and 21 boys who like science. So let's see, a boy is more likely to prefer math than to prefer science. According to these numbers, that's not true. According to my own personal intuition as a math teacher, that must be true, right? But according to these numbers over here, unfortunately, I can't check that one. A girl is more likely to prefer math than to prefer science. So here are the girls, 24 like math and 19 like science. So yeah, girls prefer math over science. Boys are less likely than girls to prefer math. Okay, so we have to be careful here because we need to really look at the relative frequencies to answer a question like this. I know that 16 boys like math, and I know that 24 girls like math. But really, that could be misleading because what if there are a lot of boys and only a few girls? Or what if there are a lot of girls and only a few boys? So, really, in order to compare these numbers, first, we would want to convert them into percents. So, I'm going to look at the boys over here. And just looking at the boys row, that's 16 out of 37 boys. So we're going to do 16 divided by 37, and that's about 43%. So let me write that. Let me just write down about 43% of the boys prefer math than science. And now let's do the same thing for the girls. So we have 24 girls out of 43 girls prefer math. So let's do 24 divided by 43, and we get about 56% if we round over here. That's an 8, so that'll bump that up to a 6. So about 56% of the girls prefer math. So looking at these numbers over here, boys are less likely than girls to prefer math. Yes, that would be true. All right, now let's look at the next one. Girls are more likely than boys to prefer science. Well, again, 21 out of 37 boys prefer science. So that would be, well, since I know that 43% preferred math, then it must be 57% who prefer science, right? But anyway, let's just do 21 divided by 37. Okay, and then I do get about 57%. Okay, so for this one here, about 57% of the boys prefer science. And now let's look at the girls. 19 out of 43 girls prefer science. So let's do 19 divided by 43 equals about 44%. Okay, and this was for the girls and this was for the boys. So it looks like girls are less likely than boys to prefer science because only 44% of them like science and 57% of the boys like science. So girls are more likely than boys? No, girls are less likely. So I'm not going to check that one. A student is more likely to prefer math than science. So over here, they just said a student, right? They're not talking about a girl or a boy. So we need to look at all the students, whether they're a girl or a boy. All right, and it looks like 40 students. Okay, so we're going to look at the total of all the people who preferred math, boys and girls. That's 40. And the total of all the people who prefer science is also 40. Okay, so it's the same number here and here. So a student is more likely to prefer math than science. No, they're equally likely to prefer math as science because it's the same number here and here. So we're not going to check this one. Boys are equally as likely as girls to prefer math. So over here, it looks like the boys, again, we have 16 divided, I should have just kept these numbers, 16 out of 37 boys. So 16 divided by 37 is 43% of the boys like math. And for the girls, it was 24 divided by 43. What, you know what? I already forgot. I'm going to write it down. 16 divided by 37. Okay, so 43% of the boys like math. Okay, and 24 out of 43 is about 56% of the girls like math. Okay, so boys are equally as likely as girls to prefer math? No, that's not true. Okay, so it looks like only these two were true. Hit submit. Got it correct. Okay, next one. Alana asked some students at her school whether they prefer to bring their own lunch or buy the school lunch. She also asked whether they prefer water or juice. This table shows the results. Okay, so out of the 72 people that she asked, 24 prefer water compared to juice, and they also bring their own lunch. They don't buy their lunch. All right. And let's say 16% prefer juice and they buy their lunch, and so on and so forth. Now let's answer the questions based on the data in the table. Which statement is true? So it looks like only one of these will be true. It doesn't look like they're letting you select more than one here. Okay, so let's see here. Students who prefer water. So now, since it said students who prefer water, I'm only going to be looking at this row over here. I'm not even going to pay attention to these juice people, because that's not what I'm interested in for this question. Students who prefer water are less likely to bring lunch than students who prefer juice. Well, let's see. Out of the people who bring water, more of them bring lunch. Okay. Oh, I'm sorry. I made a mistake. I'm sorry. No, we are interested also in the people. We're comparing it to the people who prefer juice. I'm sorry. I forget what I said earlier. So students who prefer water are less likely to bring lunch than students who prefer juice. Okay. So there were 24 out of 38 water drinkers who bring their lunch to school. Okay, so out of the water drinkers, which is 38 water drinkers, 24 of them bring their lunch to school. So 24 divided by 38 is 63%. Okay, so if we're only looking at the water drinkers, 63% of them bring their lunch to school. Now let's look at the juice drinkers. There are 34 juice drinkers, and 18 of them bring their lunch to school. Let me just copy this down so I don't forget it. This was 63. That was 63%, not of the whole total, but just out of the water drinkers. And over here, 18 divided by 34 is equal to 53%. Okay. Yeah, so it looks like students who prefer water are less. Oh, I'm sorry. No. They're more likely. There's 63% here, 53% here. Students who prefer water are more likely to bring their lunch than students who prefer juice. So this is not the correct answer. Let's try this one. Students who prefer water are as likely. So that means equally likely to bring lunch as students who prefer juice. No, that's not true. Okay, we got 63% and 53%. That's not the same. Students who prefer water are more likely to bring lunch than students who prefer juice. Yes, that one is correct, because 63% of the water drinkers bring their lunch to school. Only 53% of the juice drinkers bring their lunch to school. So submit that. Okay, next question. Miss Woodman is giving her classes a research project on historical figures of the Revolutionary War. She asked her students whether they would prefer to make a video documentary or stage a live performance. This table shows the results. So here we have boys in this row, girls in this row, students who prefer video documentaries in this column, students who prefer a live performance in this column. By the way, just a little bit of vocabulary. Rows are horizontal and columns are vertical. Okay, let's read the question. What percentage of boys would prefer to stage a live performance? So for this problem, we're just going to focus on the boys. So we're going to focus on this row over here. And there were 31 boys total. and 6 of them would prefer a live performance. So the percentage of boys who would prefer a live performance, we would get that by doing 6 divided by 31. And then we're going to move the decimal point 2 spaces to the right, 1, 2, and we would get 19.354, blah, blah, blah. 19.354, blah, 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 blah. Okay, and then it says round your answer to the nearest tenth of a percent. So before you round, you have to move the decimal point 2 spaces to the right, like we just did. So now the decimal point is here. And then the tenths place would be one place after the decimal point. That's here. And we're going to round to this place value, which means we have to look at the next place over. And if this is a 0, 1, 2, 3, or 4, then this stays the same. If this is a 5, 6, 7, 8, or 9, then this gets bumped up 1. So this is a 5, so we're going to bump this up 1. So we're going to say that this is approximately 19.4%. This was also a percent, right? 19.4%. Okay. Alrighty. Next. The superintendent of Madison School District asked 175 middle school and high school teachers whether they prefer teaching morning classes or afternoon classes. This table shows the relative frequencies from the survey. So these are percentages here, except they're in decimal form. If you want to actually turn them in percentages, you would just move the decimal point 2 spaces to the right. And once again, whenever we have a relative frequency table, this would always be as a decimal 1 or as a percent 100%. In just a regular frequency table where we know the actual number of people, then this could be anything. But in a relative frequency table, this is always 100%. Okay, how many more teachers prefer teaching morning classes than prefer teaching afternoon classes? Okay, so we have middle school teachers over here. We have high school teachers over here, but it didn't ask us specifically about middle school teachers or high school teachers. It just asked us about the teachers, right? So that means we don't care if they're middle school or high school teachers. So we're going to look at the totals, all right? So 68% of all the teachers preferred morning classes. And 32% of all the teachers, whether they were in middle school or high school, prefer afternoon classes. Now, you might be thinking that we should do 0.68 minus 0.32, and then that would be the answer, 0.36 over here. But that would be incorrect because that's just a percentage, right? What we really want to know is the number of teachers. So if there were 175 middle and high school teachers, so 175 teachers total, and 68% of all those teachers prefer morning classes, well, then how many teachers is that? We would just do 0.68 times 175. And so it's actually 119 teachers who prefer morning classes. And to figure out the number of teachers who prefer afternoon classes, then we would do this times 175. Okay, so 0.32 times 175 is equal to 56. Okay, now that I know the actual number of teachers, not just the percent of all the teachers, now I can go ahead and subtract these. So the next thing we're going to do is 119 minus 56. Okay, and that is 63. Right, now you might be wondering, do you get the same answer if you subtract these first and then multiply by 175? And the answer is yes, you would. So let's do 0.68 minus 0.32 is 0.36, like we said before. Then if we multiply that by 175, we get the same answer, 63. And you could see that it's the same thing, either strategy, because if we do, what's the first thing that we did? I mean, I already have the answer. I could click submit, but just to, just to, if you're interested, then what did we do this time? We did 0.68 times 175 in order to get this number, right? And then we subtracted 0.32 times 175. Okay, and then basically, if you notice that both of these have are being multiplied by 175, then we can factor out the 175 and we can say that this whole thing is the same thing as doing 175 times 0.68 minus 0.32. So just to check that, if you distribute this times this, 175 times 0.68 is exactly this term over here. And this times this, 175 times 0.32 is exactly this term over here. So this is exactly the same thing as doing this. So you can either multiply both of these by 175 and then subtract them, or you could subtract the percentages first and then multiply by 175. This whole thing is exactly equal to this thing. So either strategy would work. All right. So anyway, just continuing now. All right. Another one of these. In a poll, 50 7th grade and 8th grade teachers were asked whether they assign homework during winter break. Well, all right. So I guess I would be one of those teachers who assigns homework during winter break. This table shows the relative frequencies from the survey. Okay. So 12% of all the teachers surveyed were 7th grade teachers who assign homework. 32% of all the teachers surveyed were 7th grade teachers who don't assign homework. What's another one? 62% of all the teachers surveyed don't assign homework. Okay. All right. And some of those are coming from the 7th grade teachers, and some of them are 8th grade teachers. Based on the data in the table, which statements are true? Select all that apply. So there could be more than one answer here. Most 8th grade teachers assign homework over winter break. So for this one, we're only focused on the 8th grade teachers. And we can see that the percentage of 8th grade teachers who don't assign homework is greater than the percentage of 8th grade teachers who assign homework. And that, of course, would also mean that the actual number of teachers, 8th grade teachers who don't assign homework, is greater than the actual number of 8th grade teachers who assign homework. So if we wanted to know the actual numbers, then we would take these percentages and multiply them by 50. But we don't actually have to do that. Just seeing the percentages is enough. So let's see. Most 8th grade teachers assign homework over winter break. No, actually, most of the 8th grade teachers, this number is bigger than this one. So most of the 8th grade teachers do not assign homework over the winter break. So this is false. We're not going to check that. So the next problem is teachers who assign homework over winter break. So we would be looking at this column over here for the teachers who assign homework are more likely to teach 8th grade than to teach 7th grade. So if I'm talking to a teacher who I know assigned homework over winter break, and I'm wondering to myself if that's a 7th grade teacher or an 8th grade teacher, well, it looks like there were more 8th grade teachers who assigned homework than 7th grade teachers who assigned homework, right? Because I know the percentages are higher for 8th grade. Therefore, also the actual number of teachers of 8th grade teachers who assigned homework is larger than the number of 7th grade teachers who assigned homework. So it would be more likely if they assigned homework that they're an 8th grade teacher, more likely to teach 8th grade than teach 7th. So yes, that would be correct. There is an association between grade level and whether or not teachers assign homework over winter break. So this just means, is there some kind of relationship between what type of teacher you are, a seventh grade teacher or an eighth grade teacher, and whether or not you assign homework over winter break? Yeah, there does seem to be some kind of relationship. It looks like seventh grade teachers are a little bit less likely to assign homework over winter break, right? So yeah, there is some kind of association. So we're going to check that. There is some relationship. There is no association between grade level and whether or not teachers assign homework over winter break. So we would only check this if all the numbers for the seventh grade teachers and the eighth grade teachers were exactly the same. Um, but I can, based on knowing if a teacher is a seventh grade teacher or an eighth grade teacher, I can use that to predict how whether or not they assigned homework or didn't assign homework. I might be wrong with my prediction, but there is some relationship there. So we're not going to check this one. All right, and that should be right. Okay. Next one. Luther is planning the music for his school's pep rally. He asked a group of seventh and eighth graders whether they prefer pop music or rock music. This table shows the results. How many more students prefer rock music than prefer pop music? So this is a frequency table. So we have the actual number of students in all of these boxes over here, in all of the cells of this table. It's not a relative frequency table. We're not shown percentages here. We're shown the actual numbers. So this should be easy to answer. How many more students prefer rock music than prefer pop music? So you just have to be careful that it's asking you about the students in general. It's not saying how many more seventh graders prefer pop music than eighth graders. It's not asking us about seventh grade or eighth grade. It's asking us about all the students. So, how many students, whether they're seventh graders or eighth graders, prefer pop music? That's 22. How many students, and again, I don't care if they're a seventh grader or an eighth grader, how many prefer rock music? That's 38. Okay, so how many more students prefer rock music than pop music? We would just do 38 minus 22, which is 16, right? You could 38 minus 22, 16. Okay, so let's put that in there. All right, let me do one more. They're starting to get, I think, a little bit repetitive. I think we've seen every type of problem in this exercise. I'll do one more. Alexandra asked 75 students at her school whether they are right-handed or left-handed. This table shows the results. How many more girls than boys did Alexandra survey? Oh, excuse me, that's an easy one. So how many boys did she survey? Well, she surveyed a total of 32 boys, right? Regardless of whether they were right-handed or left-handed. It was 32 boys. It was 43 girls. So if I want to know how many more girls than boys did she survey, then I would just do 43 minus, minus 32, which is 11. Okay, and that's it. Let's see. I'm in the challenge zone. All right, but I think we've done. You know what? All right, I'll do one. I'll do one more. Last one. The students in Miss Carter's science classes just finished their end of the year projects. The students chose between studying an endangered animal or an extinct animal. They also chose between creating a video or a slideshow for their project. This table shows the results. Based on the data in the table, which statement is true? The students who did a project on an endangered animal were less likely to make a video than those who did a project on an extinct animal. The students who did a project on an endangered animal, okay, so that was these students over here, were less likely to make a video than those who did a project on an extinct animal. So that's these kids over here. So let's look at the students who made students who looked at an endangered animal who made a video, that was 23 out of 69. Okay, so let's do 23 divided by 69. So of the students who studied an endangered animal, 33% of them made a video about it. Okay, so I'm going to write that down. Okay, 30. This is 33%, not 33% of everyone that of this, 33% of the 69 students who studied endangered animals. And over here, 15 divided by 45, well, that's going to be exactly the same thing. 15 divided by 45 is also 0.3 repeating, or approximately 33%. Okay, so they were just as likely to make a video. The students who studied endangered animals were just as likely. They were equally likely as the students who studied an extinct animal to make a video. So not less likely. So this one is not true. We're not going to pick that one. What about this one here? The students who did a project on an endangered animal were as likely to make a video as those who did. Oh, well, yeah. So we just figured that out. It's this one, right? Okay. So we're going to submit that. Brilliant. Yeah, you have to be careful with those. If you're talking about more or less likely, then you really want the relative frequency. So you have to be careful there, and you're going to need to divide by one of the totals. Okay. Oh, here's a type of problem we actually haven't done before. I keep saying this is the last problem I'm going to do, and then I find a problem that we haven't done yet. Okay, so I'll do this one. Philippe asked 50 students at his school whether they would prefer to go to the mountains or the beach on vacation. This table shows the results. All right, so 10 students were seventh graders who want to go to the mountains, and 9 were seventh graders who want to go to the beach, and so on. Use the table to complete the sentence. Students are more likely to prefer the blank because blank of students surveyed prefer the beach and blank of students surveyed prefer the mountains. Oh boy. Okay. Students are more likely to prefer. Okay, so this, first of all, says students. It doesn't say seventh grade students or eighth grade students. So let me just look at the total over here. There were 22 students who prefer the mountains, and there were 28 students who prefer the beach. So students are more likely to prefer it looks like they're more likely to prefer the beach because blank of students surveyed prefer the beach. Okay, well, let's see. There were 28 students who preferred the beach out of a grand total. Again, for this situation, I don't care if they were a seventh grader or an eighth grader, right? It just says students over here. So there were 28 students who preferred the beach out of a grand total of 50. So that would be 56%. If you just do 28 divided by 50, then you'll get 0.56, which is 56%. So we're going to put that there. Okay, and then students are more likely to prefer the beach because 56% of students surveyed prefer the beach, and blank percent of students surveyed prefer the mountains. So now let's just do 22 divided by 50. All right, 22 divided by 50 is equal to 44%. So we'll put that there. Okay, and again, I talked about this in another video, but if you're wondering how I was able to do that in my head, it's actually not that hard. So if I want to do 20, convert this into a percent, well, I know that a percent is really a fraction out of 100. So 22 over 50, I should ask myself, is equal to what over 100? Well, to get this to be 100, I would multiply by 2. So really, in my head, I was just multiplying 22 by 2, and that's 44. So 22 out of 50 is the same thing as 44 out of 100, which by definition is 44%, because percent just means out of 100. Okay, So you don't really have to know that for this IXL exercise. I just thought I would talk about it. Let's hit submit there. Oh, I'm done. All right, good. Good for me. Okay, so I hope you enjoyed that video and have a great day.